Somewhere out there, 73 light-years away, something the size of Jupiter is orbiting an object that isn't a star. It isn't a planet either. Astronomers just found it, and they still don't know what to call it. Not because the data is unclear, the data is solid, they just ran out of words. This is the story of CD-35 2722. And by the end, you're going to realize the universe has been hiding entire categories of objects we never even thought to look for. Let's start with what we thought we knew. In our solar system, the rules are simple. You've got a star. Planets orbit the star. Moons orbit the planets. Clean. Tidy. Easy to draw on a whiteboard. CD-35 297222 breaks that whiteboard. It's a star sitting 73 light-years from Earth in the constellation Columba. About half the mass of our Sun. Nothing unusual so far. But orbiting that star is something strange. A brown dwarf. Scientists sometimes call these things failed stars. And that name isn't just dramatic flavor text, it's literal. A brown dwarf forms the same way a star does, gas collapsing under its own gravity, but it never gathers enough mass to ignite. No fusion, no sunlight of its own. Just a dim, smoldering leftover forever stuck between planet and star. This particular failed star is called CD-35 2772b. It's about 37 times the mass of Jupiter. Too heavy to be a planet. Too light to be a star. Already this system doesn't fit the categories we grew up with. Picture it for a second. A dim, reddish-brown ember, drifting through the dark, radiating faint heat instead of blinding light. Not dead, not alive, just stuck. Forever hovering in the gap between two categories that were never designed to hold something like it. And here's where it gets stranger, because CD-35 2722b has something orbiting it too. For years, astronomers suspected there might be something out there. A team led by Kevin Hoy at the Universidad Diego Portales in Chile spent from October 2023 to February 2026 watching this brown dwarf night after night, using the CRI-RES Plus instrument on the European Southern Observatory's Very Large Telescope. They weren't looking for a picture, they were looking for a wobble. Here's how it works. If something massive is orbiting an object, its gravity tugs on that object just enough to make it shift, ever so slightly back and forth. You can't see the orbiting object directly, but you can measure the tiny wobble it causes in the light of the thing it's circling. Think of it like watching someone stand still while holding a leash with a dog you can't see tugging on the other end. You never see the dog, but every pull, every shift in the person's stance tells you it's there, and roughly how strong it is. It's the same method that found the very first exoplanet ever detected around a sun-like star back in 1995. A technique already proven, already trusted, now pointed at something nobody had tried it on before. A brown dwarf instead of a star. 23 high-quality observations later spread out over more than 2 years of patient. Repeated watching, the wobble was undeniable. Something was out there. Something massive. Something orbiting the brown dwarf itself, not the star. The object has a minimum mass of about 90% of Jupiter's. It completes an orbit roughly every 170 days. It's a giant gaseous body, and it is absolutely, unmistakably real. So what do you call it? This is where the story stops being simple physics and starts being an identity crisis for the entire field of astronomy. Think about the hierarchy here. You've got a star. Orbiting the star, a brown dwarf, an object so massive it's basically a star that failed to light up. And orbiting that failed star, a third object, roughly the mass of Jupiter. If you follow the logic of our solar system, that third object should be a moon, as the smallest thing in the chain. It orbits something that orbits something else. That's exactly what a moon does. But nothing about this object looks like a moon. Our moons are small, rocky, quiet little worlds. This thing is a giant ball of gas, nearly as massive as the largest planet in our solar system. Calling it a moon feels almost insulting to the word. Alice Zurlo, an astronomer on the Discovery team, explained the core problem. In our solar system, you always know what's a star and what's a planet. Because the boundary is obvious. That obvious boundary is the only reason scientists can agree on what counts as a moon. Take that boundary away, like in the CD-35 2722 system, and the whole naming system starts to fall apart. And she's not exaggerating. Some scientists studying this discovery have openly disagreed with each other. Some argue the object should be classified as a moon because it's the third tier in the hierarchy, orbiting something that orbits a star. Others say that's absurd. They argue anything with the mass of Jupiter is, by definition, a planet, no matter what it's circling. One researcher involved with the discovery summed up the confusion a different way. Our usual vocabulary just doesn't stretch to cover this kind of object. It's massive enough to earn the label planet on its own, but it doesn't circle a star directly. It circles something that circles a star. That extra step in the chain is why everyone keeps reaching for the word moon. Even though it looks nothing like the small, rocky moons we grew up with, nobody has a clean answer. And that's not a failure of the research. That's the actual discovery. Some astronomers outside the discovery team have already weighed in publicly, and the disagreement isn't quiet. A few argue this case is actually simple. Anything with roughly the mass of Jupiter should just be called a planet. Full stop, regardless of what it happens to be circling. Others push back hard on that, pointing out that calling a brown dwarf's companion a planet opens the door to calling brown dwarfs themselves stars, which most astronomers already refuse to do. There's no vote happening here, no committee meeting to settle it. Just researchers in papers and interviews quietly disagreeing with each other in real time, while the object itself keeps orbiting, completely indifferent to what we decide to call it. Here's the thing that makes this even weirder. This isn't even the first time astronomers have spotted something like this. Back in 2005, the Very Large Telescope found an object up to 6 times the mass of Jupiter, orbiting a different brown dwarf called 2M1207. Nobody called that one a moon either. It just sat there, unclassified, for over 20 years because scientists weren't ready to build a category for it. 20 years? Think about that. An object massive enough to dwarf every planet in our solar system except Jupiter itself, sitting in plain sight in published data, and the scientific community simply left it unnamed. Not because they missed it, because they didn't know what box to put it in, so they left the box empty. So this isn't a one-off oddity. This might be a whole class of objects we've been quietly ignoring because they didn't fit anywhere on our chart, and CD-35 2722 might just be the first one solid enough and clear enough that we can no longer pretend the box isn't needed. Now let's get to the part where this stops being just a naming problem and starts being genuinely unsettling. If you're enjoying peeling back the layers of stuff hiding in plain sight, subscribe, because this channel exists for this kind of discovery, the ones that quietly rewrite the rulebook. If this classification holds, and researchers are already treating it as one of the strongest candidates ever found, this could be the first confirmed exosatellite in history. Not a planet orbiting a star, not a moon orbiting a planet in the way we understand moons. Something new. A gas giant orbiting a failed star in a system where the traditional definitions of star, planet, and moon all quietly stop making sense. And if you're wondering how big a deal that actually is, consider this. We've cataloged thousands of exoplanets since the first ones were confirmed in the early 90s. Thousands. And in all that searching, moons around those exoplanets have remained almost completely invisible to us. We've suspected they're out there. We just haven't had the tools or the luck to catch one. This might be the closest we've ever come, and it didn't even look the way we expected an exomoon to look. For decades, the hunt for exomoons focused almost entirely on moons circling actual planets, the kind we'd recognize, small rocky bodies like our own moon, or icy worlds like the ones circling Jupiter and Saturn. Nobody was really watching brown dwarfs for satellites of their own because brown dwarfs already sit in such a strange, in-between category that adding a fourth layer of complexity seemed almost unnecessary. CD-35 2722 just proved that assumption wrong. Now here's the part that should really sit with you. This system was already known. The brown dwarf, CD-35 2722b, was first spotted back in 2011 through direct imaging. Astronomers have had their eyes on this exact patch of sky for over a decade. And this entire time, there was a Jupiter-sized object hiding in orbit around it, invisible, undetected, simply because nobody had pointed the right kind of instrument at it in the right way. Direct imaging can show you a bright object. It can't always catch something small enough or dim enough, tucked in close orbit around something else. It took a completely different technique, radial velocity, measuring a wobble instead of chasing a picture, to finally reveal what had been there the entire time. Which raises the question this discovery really leaves behind. How many other systems have we already photographed, already studied, already filed away as known and understood, that are hiding something exactly like this? A gas giant, an exosatellite, an entire hierarchy of orbiting bodies we never thought to look for, because we were only looking for the kinds of objects we already had names for. CD-35 2 didn't just break the rules about what counts as a moon. It exposed how much of what we call known space might just be the stuff we happen to notice first. Kevin Hoy and his team are still watching this system. More observations are planned to nail down the object's exact mass, its full orbit, whether it has an atmosphere of its own. But even if every detail gets pinned down perfectly, one thing won't change. We're going to need a new word for what's out there, and somewhere in a system we've already looked at 1,000 times, there might be another one waiting right now for someone to finally ask the right question.